Welcome to the Walton Pie. Today we are going to be talking about the ratio test to test for convergence of a series. So the ratio test is used to determine if a series is absolutely convergent. So we have a theorem that says that if a series is absolutely convergent, then it is also going to be convergent. So the ratio test will test if something is absolutely convergent, and then that can be used to show that those series are also convergent. Note that this means that this is not going to give us a result for series that are convergent but not absolutely convergent. So if we have a series of the form, the sum from n equals 1 to infinity of a sub n, the ratio test tells us that if the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, if that is equal to some limit which is less than 1, then the series is absolutely convergent. If the limit is greater than 1, then the series is going to be divergent, and our only other case is if the limit is equal to 1, then this test actually told us nothing. So it could diverge, it might converge, it might diverge, we're not sure. This test did not tell us anything about the convergence or divergence of that series. However, in the first two cases, it is going to be definitive. If the limit of the ratio is less than 1, then the series will converge. If the limit of the ratio is greater than 1, then the series will diverge. That is what the ratio test tells us. So it does not always give us a definitive answer. So that tells us that a good rule of thumb for when it is going to give us a yes or a no is if there are any factorials or exponentials like a to the n or n cubed in the terms of the series. It is quite likely that the ratio test will give you a yes or a no answer. But even in situations where those don't show up, you can always calculate the limit and hope it works out. Just remember that if the limit is 1, then the test didn't tell us anything. We have to find a different test to figure out if it converges or diverges. So let's do an example. Let's look at the sum from k equals 1 to infinity of 1 over k factorial. Well, the limit as n goes to infinity of our n plus 1th term over our nth term, so that's going to be 1 over n plus 1 factorial all over 1 over n factorial. That's the limit as n goes to infinity of n factorial over n plus 1 factorial, which is the limit as n goes to infinity of 1 over n plus 1, which is 0. 0 is less than 1, so that tells us that this series is absolutely convergent, and therefore is also just convergent. Let's do another one. Let's do the sum from n equals 1 to infinity of 2n factorial over n factorial squared. So the limit is n to infinity of our n plus 1th term over our nth term, that gives us 2n plus 2 factorial over n plus 1 factorial squared, all over 2n factorial over n factorial squared. This is the limit as n goes to infinity of n factorial squared times 2n plus 2 factorial all over n plus 1 factorial squared times 2n factorial. That, after canceling, gives us 2n plus 2 times 2n plus 1 over n plus 1 squared, which is 4n squared plus 6n plus 2 all over n squared plus 2n plus 1. If we look at that limit, we can divide the top and bottom by n squared, and we are left with a 4 plus 6 over n plus 2 over n squared over 1 plus 2 over n plus 1 over n squared. That limit is 4, which is bigger than 1. So that means that this series diverges. I hope this video was helpful in understanding the ratio test. Please check out some of my other videos, and please like and subscribe if you haven't already, so I can continue to make these sorts of videos. Have a great day, and good luck with the rest of your math.